Hello everyone, welcome back to my YouTube channel. In today's video byte, we are going to discuss about the properties of a transmission line. When I say properties of a transmission line, we are going to discuss about the basic properties that are being used by a signal integrity engineer while analyzing a particular transmission line. Majorly, there are two types of transmission lines that are being used in the industry. One is the microstrip and the other is the strip line. When I talk about microstrip are the transmission lines that are on the top or the bottom layer of the stack up. And when I talk about strip line, these are the transmission lines that are embedded somewhere inside your stack up. Like for example, if you are taking a layer 1 to layer 10 board, and if your transmission line is between layer 2 to layer 9, they are known as the strip line traces, and if they are on the top or the bottom layer, they are known as the microstrip traces. Being a signal integrity engineer, you need to focus on the pre-layout analysis as well as post-layout analysis. When I talk about the pre-layout analysis, at that time you need to discuss on the properties of the transmission line that you are going to create, or the traces that you are going to create. So whenever you are going to check the properties of a transmission line, majorly there are two properties that comes into picture. Number one is the speed of the signal in the transmission line, and number two is the propagation delay. Propagation delay is nothing but the delay occur in the transmission line due to all the materialistic losses. So these two properties are the one that we are going to discuss now, and the formulation for them, so that it becomes easy for a signal integrity engineer to analyze and check what is the speed of the signal in my particular transmission line, and as well as the propagation delay, how much propagation delay I am getting while my signal travels from my transmitter to my receiver. Let us quickly discuss about the first property of a transmission line, that is speed of the signal. When we say speed of the signal, we usually talk about the signal propagation speed, and it depends on the material it travels and it is surrounded by. When I say material in it travels is the copper. We are talking about the copper, as well as we are going to talk about the dielectric, whichever the dielectric you have used. So the speed of the signal usually depends on both. First is the medium it is traveling inside, that is copper, and the dielectric material which is surrounding it. In order to derive the formula for signal propagation speed, we need to check the speed of light. So Vc is termed here as speed of light, that is 3 into 10 raised to the power 8 meters per second. And what we have done here is we have just converted into inches per nanosecond. We have done our mathematics and we have converted 3 into 10 raised to the power 8 meter per second into inches per nanosecond, which comes around 12 inch per nanosecond. 12 inch per nanosecond. Now, when we want to discuss about the speed of propagation of a signal in a transmission line, in PCB, as I mentioned earlier, there are two type of majorly used transmission line. One is microstrip and the other is strip line. So the formula is going to be changed for both microstrip and strip line. The main reason behind this is because strip line is an embedded trace which is in the middle layers, somewhere in the middle in your transmission line stack up. But when we talk about the microstrip, the one side is connected with the dielectric and the other side is connected with air, or which is exposed to air actually. So the formulation also changes for both microstrip and strip line traces. So the signal travels on a transmission line at a slower speed. As we all know, the copper as well as dielectric losses will come into picture. So speed of light is 3 into 10 raised to the power 8 meter per second, that is 11.8 inches per nanosecond. But when the signal travels in a particular transmission line, it slows down. And it is because of the dielectric constant, that is epsilon r, and as well as the copper losses that are there. So the resistive as well as the RLC property of the copper also plays a major role. So let us see what is the formula for the speed of signal in a transmission line. So the speed of signal in a strip line is given by Vs, which is merely equal to Vc upon underscore epsilon r, where your epsilon r is nothing but your dielectric constant. When I talk about the microstrip signal, so the formula changes adds epsilon r effective. When I say epsilon r effective, so you need to calculate the value of epsilon r effective. And the major reason why we have used epsilon r effective instead of epsilon r is the stack up of this particular trace. So when we talk about microstrip are on the top layer or on the bottom layer. Okay. So as you can see in the diagram, so half of these traces are exposed to air, and some part of this transmission line is exposed to the dielectric constant. So we cannot take this whole as a dielectric material, okay, because the property of air is different as well as the property of a dielectric material is different. So then how we are going to calculate this epsilon r effective? So we do have a formula for epsilon r effective, which is given here as epsilon r effective, which is merely equal to 0.64 epsilon r plus 0.36. When you use this formula, you will get the value of epsilon r, which can be fed back to this formula of speed of signal in microstrip, and you can get the speed of the signal in the microstrip also. So first property we have discussed is the speed of signal, which is an important property where you are going to see how fast my signal is traveling in my particular transmission line and how my copper as well as dielectric losses are affecting it. Let's discuss about the second and the foremost important property of a transmission line, that is propagation delay in the transmission line. When I say propagation delay, just understand this in such a way: my signal is traveling from TX to RX, and because of this copper trace, because of the traces, vias, as well as whatever is inside that transmission line channel, we are going to see some sort of delay because of the materialistic property of copper as well as the dielectric material. So we are going to see that property over here, and we'll get to know how much my signal is getting delayed when it starts from transmitter to receiver. So we are going to analyze this in some sort of a time domain analysis. So this is the formula for the transmission line propagation delay, where TPD is equal to L by V. So whenever I say length, which means L is the length of the trace and V is the velocity of the signal. So this V value can be changed for microstrip. Microstrip it is different, and for strip line it is different. For strip line also it is different. So as in my earlier slide I have mentioned about both the formulas. So all you need to do is you need to calculate the value for velocity, and you have to keep this value over here. In some of the major books you will see the transmission line propagation delay is defined as a per unit length entity. So even you can do that also. So that will make TPD equal to 1 by V, and then you need to multiply this with the total length of your transmission line. Then you will get the transmission line propagation delay for the whole length. In this video, we have seen the two major properties of a transmission line. First is the speed of signal, and the second is the propagation delay. Now I have a question for all of you. Let's solve a question based on the numerical formula of transmission line speed as well as transmission line delay. So the question says, calculate the propagation delay of a signal traveling in a trace of length. I have given the length of the trace, that is 12 inches, and the dielectric material used is Fr4. So I have already given you the value of epsilon r, that is 4. Now tell me the value of strip line trace. What will be the transmission line propagation delay for strip line as well as for microstrip? Please put your answers in the comment box, and if you face any difficulty in this regard, please feel free to comment down below. Thank you and have a nice day.